Hi, I'm Rob Tweed, the developer behind the QEWD platform and QEWD-JSdb. And in this fourth video on QEWD-JSdb, I want to look at the way you can navigate between document node objects within an on-disk object. As before, I recommend you watch the previous videos before watching this one. The links to the series so far are in the YouTube comments below this video. Also, as in the previous two videos, I'll be using the JSDB shell in the node REPL in this terminal window, and the QEWD-JSdb viewer application running in my browser. The first thing I'm going to do is to create some test data by defining an object. And I'll save that to disk. You should be familiar with these steps by now. And as explained in the previous videos, you see the stored version in the viewer application here in the browser. So now I'm going to instantiate a document node object in the normal way. In previous videos, you've learnt that document node objects represent the on-disk unit of storage. The use method that I invoked here allowed me to specify an absolute reference to the document node object I wanted, in this case representing this part of the global storage, and these keys in the JSON that it represents. All JSON documents are hierarchical, and when manipulating and processing a JSON document, you often need to navigate around the levels within that hierarchy. Although you could use absolute references to document node objects to do this when handling on-disk JSON documents, QEWD-JSdb provides an alternative mechanism which allows you to specify relative references. In other words, from one document node object, you can navigate to its surrounding document node objects. Each document node object has getter properties that return the other document node objects that surround it within the hierarchy tree. So for example, the parent property returns a document node object that, not surprisingly, represents the parent of the one we're referencing. In other words, params represented this part of the storage, and its parent is this. We can check that by looking at their paths. And you can see the keys that we'd expect. And of course we could fetch the subset of the JSON that the parent node represents. And again, this is what we'd expect to see. You can chain these properties, so for example, and we could go up again, which as you can see has taken us to the top level, the global itself. So from this we could get the entire JSON that I saved coming back by doing this. Once you're using a document node object that represents the top level of the on-disk document hierarchy, as we are now, its parent will return undefined, as you can see. So that's the parent property. The next properties to look at are the sibling ones. We can get to a document node's previous or next sibling. So for example, from our params node, we can get its previous sibling. Let's look at its path, which is what we'd expect, and we can return its value, which again is what we'd expect. Now we could of course have chained these and obtained this value in one step. An important thing to note here, what we're doing is accessing the data directly on disk. Nothing is being moved in and out of in-memory JavaScript objects here. We're interacting directly with the data in the database. So that means I could change the actual stored value on disk directly. So that's previous sibling. You can also get the next sibling. And let's look at its keys, which again are what we'd expect. So in other words, the next sibling of the document node representing these keys represents this. As with the parent property, trying to access a non-existent previous or next sibling will return undefined, as you can see if I try this. It's undefined because PS, which is this node, has no previous sibling. Or we could try this, and it's undefined because NS, which is this node, has no next sibling. The next thing we can do is navigate to a document node object's child nodes. We can get directly to the first and last child nodes. So in other words, from our params document node object, which represents this, to these child nodes. We can get the first child by doing this, and as you'd expect, shows that it's this node. Alternatively, we could have got to the last child using this. So what about the second child, database? To get that, we could do this. And from there, we could get its first child. Chaining these child and sibling references is fine for this example, where there are just small numbers of child nodes. But how about in this section of the saved data, which, as you can see, has a large number of child nodes? Well, let me instantiate that node, which, by the way, we could have also got to with this. I'll let you figure out how and why that's the case. Anyway, for this node, its first child is this, and its last child is this. But if I wanted this child, I'd have to chain down a large number of next sibling nodes. And that's clearly not very convenient. QEWD-JSdb provides a much slicker mechanism. Suppose I know the name I'm looking for, let's say Finlay. I could actually get directly to it using a document node object method named $. Let's try that out. So the $, method returns a specified child document node object where the argument is the key that you're wanting. Now what happens if I specify one that doesn't exist? For example, if I do this. You may be surprised to find that it doesn't return an undefined. And that's because it's the equivalent of doing this. And as we saw in previous videos, a document node object represents an on-disk storage node that may or may not currently exist. In our case, foo does not yet exist as an on-disk node, but it's quite legitimate to instantiate it. It turns out this is quite handy. It means we could use it to add another name to our stored list. However, you'll see that the way they're structured in this example, there's a further key representing an ID number after the name. As before, however, we can chain the $, methods, since each returns a document node object. So I could add a new name to our list like this. And bingo, here's the new saved record. Chaining multiple $, methods like this can get very verbose, and each one needlessly instantiates a document node object. So the $, method can also take an array as an argument, and we could do this instead, which can be much cleaner. The $, method turns out to be one of the key, important and powerful methods for document node objects, and it's one of the most frequently used features of QEWD-JSdb. So that's it for this video. In the next video we'll look at how QEWD-JSdb allows you to iterate through the keys of an on-disk JSON document, another of the powerful and fundamental techniques provided by QEWD-JSdb. For now, thanks for watching, and see you in the next video.